Yellowstone. The name evokes images of breathtaking wilderness, vast forests, and iconic wildlife. It's a sanctuary of natural beauty, home to more geysers and hot springs than anywhere else on Earth. But beneath this serene landscape lies a geological titan, a feature that has captured the public imagination and fueled countless disaster headlines: the Yellowstone Supervolcano. We've all heard the whispers and seen the sensationalist reports. They paint a picture of a ticking time bomb, a catastrophe overdue that could plunge the world into a volcanic winter. But how much of this is Hollywood fantasy, and how much is scientific reality? Is a super eruption truly imminent, or is the truth far more complex and ultimately less terrifying? To find the answer, we must separate fact from fiction and explore the incredible forces that shape this land and continue to stir beneath it. The story of Yellowstone begins deep within the Earth. Its entire volcanic personality is not born from the crashing of tectonic plates like the volcanoes in the Ring of Fire, but from a geological feature known as a hotspot. Think of it as a colossal stationary blowtorch of superheated rock, a plume rising from the depths of the mantle that has remained in the same spot for millions of years. Above this plume, the North American tectonic plate has been slowly sliding, like a piece of paper being dragged over a candle flame. As the plate drifts southwestward, the hotspot continuously punches through the crust, leaving a trail of volcanic activity in its wake. This process has created the chain of ancient calderas that now form Idaho's Snake River Plain, a geological breadcrumb trail leading directly to its current location, right under Yellowstone National Park. This hotspot is the engine that drives everything we see in Yellowstone, from its past cataclysms to its present-day wonders. The most dramatic evidence of the hotspot's power is the Yellowstone caldera itself. This massive depression, spanning a staggering 70 by 45 kilometers, is what scientists refer to as a supervolcano. It wasn't formed by a single mountain peak exploding, but by the ground itself collapsing after eruptions of an unimaginable scale emptied vast magma chambers below. Over the last 2.1 million years, the hotspot has fueled 3 of these cataclysmic caldera-forming events. The most recent, the Lava Creek eruption around 631,000 years ago, was a staggering 1,000 times more powerful than the 1980 eruption of Mount St. Helens. It blanketed half of North America in ash. And even that was dwarfed by the Huckleberry Ridge eruption 2.1 million years ago, one of the largest volcanic events known to science. These weren't just eruptions, they were planet-altering events that shaped the continent's geology. So if the last super eruption was over 600,000 years ago, what are we seeing today? The answer is the park's famous hydrothermal activity. The geysers, hot springs, fumaroles, and mud pots are the modern and much gentler expression of that same deep heat source. They are part of a dynamic plumbing system. Rain and snowmelt seep down through cracks in the Earth's crust, sometimes for miles. This water is then superheated by the residual energy of the magma chamber that lies just a few kilometers below the surface. Now buoyant and under immense pressure, the water races back up, bursting forth as the spectacular features that draw millions of visitors. This constant vibrant activity is not a warning sign of an impending disaster. On the contrary, it's the sign of a healthy, stable volcanic system, safely releasing its immense energy day by day. To truly understand Yellowstone, we must first look deep into its cataclysmic past. The park's serene beauty masks a history of violence on a planetary scale. The Yellowstone hotspot has produced 3 of the largest volcanic eruptions known to science. The first, the Huckleberry Ridge eruption 2.08 million years ago, was an almost unimaginable event. It ejected over 2,450 cubic kilometers of rock and ash. That's enough material to bury the entire state of Texas 5 feet deep. It created a caldera over 75 kilometers long and earned the highest possible ranking on the Volcanic Explosivity Index, a VEI 8. The second major event, the Mesa Falls eruption 1.3 million years ago, was the smallest of the 3, but still a colossal blast that expelled 280 cubic kilometers of material. Finally, 631,000 years ago, the Lava Creek eruption occurred. This blast formed the Yellowstone caldera as we know it today, a massive 55 by 72 kilometer depression, and blanketed most of North America in a layer of ash, profoundly altering the global climate. These super eruptions are what capture the headlines, fueling nightmares of a volcanic apocalypse. But they are not the whole story. In fact, they are the rarest form of activity at Yellowstone. The geological record tells a much more nuanced tale. In the vast stretches of time between these caldera-forming events, And in the 631,000 years since the last one, Yellowstone has been far from dormant. It has produced numerous much smaller eruptions. At least 80 non-explosive lava flows have been mapped. These are typically rhyolitic lava flows, thick, viscous magma that oozes onto the surface rather than exploding violently. While locally hazardous, they move slowly, often only a few feet per day, and pose no threat on a continental or global scale. Even more common are hydrothermal explosions. These steam-driven blasts occur when superheated water trapped underground flashes to steam, shattering the rock above. The 1350 BC explosion that formed Mary Bay on the edge of Yellowstone Lake is a prime example, a powerful local event, but driven by water, not rising magma. This brings us to the most persistent myth about Yellowstone, the idea that it is overdue for another super eruption. The logic seems simple. The first interval was about 800,000 years, the second was about 670,000 years. People average these two periods, get a number around 735,000 years, and since the last eruption was 631,000 years ago, they conclude we are ticking towards a scheduled catastrophe. This is a fundamental misunderstanding of geology and statistics. Volcanoes are not metronomes. They don't follow human-made schedules. Calculating an average from just 2 data points is statistically meaningless. It's like flipping a coin twice, getting 1 heads and 1 tails, and declaring that the universe mandates a perfect alternation forever. The term geologists use, recurrence interval, is simply a statistical average of past events, not a prediction of future ones. There is no evidence to suggest the volcano is on a timer. In fact, it's entirely possible the Yellowstone system is slowly waning and may never produce a super eruption again. The overdue narrative is compelling drama, but it is not sound science. So if we can't rely on a calendar, how do we know what's happening beneath the surface? The answer lies in constant, vigilant monitoring. The Yellowstone Volcano Observatory, or YVO, a partnership between the U.S. Geological Survey, the University of Utah, and Yellowstone National Park, operates one of the most sophisticated volcano monitoring networks on the planet. They are the authoritative source, and their data shows no evidence whatsoever of an impending eruption. Let's look at what they're tracking. First, seismicity. Yellowstone is one of the most seismically active areas in the country, experiencing 1,000 to 3,000 earthquakes every year. The vast majority are too small to be felt. These often occur in swarms, where many small quakes happen in a localized area over days or weeks. These swarms are not magma breaking rock to reach the surface. Instead, they are typically caused by the movement of hot water and steam through the crust's existing fractures, or by regional tectonic stresses. Scientists are watching for a very different pattern: intense, escalating swarms of earthquakes that become progressively shallower, signaling magma forcing its way upwards. This is not what we see. Next is ground deformation. The ground at Yellowstone is literally breathing, rising and falling in a slow, cyclical rhythm. Using high-precision GPS stations and satellite-based radar called INSAR, scientists can measure changes in elevation down to the millimeter. From 2004 to 2010, the caldera floor rose by as much as 10 inches. Then the trend reversed, and it began to subside. This breathing is driven by the recharge and discharge of the vast hydrothermal system and the pressurization and depressurization of the deeper magma reservoir. It's a normal process for a living caldera, not a sign of imminent eruption. A true warning sign would be rapid, sustained uplift of meters, not centimeters, concentrated in a specific area. Scientists also meticulously monitor gas emissions. The magma chamber deep below releases gases, primarily carbon dioxide, which then travel up and mix with the hydrothermal system. The key gas to watch for is sulfur dioxide, or SO2. A sudden dramatic increase in the amount of SO2 being released at the surface would be a major red flag, as it indicates that magma has risen very close to the surface, allowing the gas to escape directly without being scrubbed by the hydrothermal system. Current gas levels at Yellowstone are stable and consistent with a deep magmatic source and an overlying hydrothermal system. Finally, thermal monitoring. Using thermal imaging from satellites, aircraft, and on-the-ground instruments, YVO keeps a close eye on the temperature of the park's hundreds of geysers, hot springs, and fumaroles. While minor fluctuations are normal, the emergence of new, rapidly expanding thermal areas or a dramatic, widespread increase in ground temperature could signal a change in the magmatic system below. To date, no such anomalous changes have been observed. All this data, The constant small earthquakes, the gentle rise and fall of the ground, the steady release of gases, paints a picture not of a monster about to awaken but of a complex, dynamic system that is breathing. These are the normal vital signs of an active but currently stable hydrothermal magmatic system. Should this change, the signs would be unambiguous and impossible to miss. A pre-eruptive sequence would likely unfold over weeks, months, or even years, giving authorities ample time to prepare. Yellowstone is not a ticking time bomb, it is a magnificent natural laboratory, and scientists are watching its every breath. When we hear the word Yellowstone, it's often followed by supervolcano. The image that comes to mind is one of global catastrophe, an earth-shattering event that changes the world as we know it. But what does the science actually say? What are the real, tangible risks we face from this incredible geological wonder? To understand the future, we must first separate Hollywood fiction from scientific fact and look at the most probable scenarios, not just the most dramatic. The most common and likely volcanic events at Yellowstone aren't eruptions of magma at all. They're hydrothermal explosions. The park is home to the world's largest hydrothermal system, a vast underground plumbing network of hot water and steam. Occasionally, if the pressure in this system drops suddenly, superheated water flashes violently into steam, expanding to over 1,500 times its original volume. This creates a localized but still dangerous explosion of steam, water, and rock. These events have happened frequently in Yellowstone's recent geological past, creating craters several hundred feet across. While they pose a serious threat to anyone in the immediate vicinity, they are not precursors to a larger eruption, and their impact is confined to a small area within the park. The next most likely scenario is a lava flow. But again, this is nothing like the fast-moving rivers of fire you might see in Hawaii. Yellowstone's magma is primarily rhyolite, which is extremely thick and viscous, more like slow-moving bread dough than liquid. The last time a lava flow occurred here was about 70,000 years ago. If one were to happen today, it would be a very slow-motion event. The flow would advance at a walking pace, perhaps only a few hundred feet per day, and would likely be contained entirely within the Yellowstone Plateau. It would be destructive to the land it covers, certainly, but it would not be a rapidly unfolding disaster and would pose no direct threat to communities outside the park. And what about the big one, the cataclysmic supereruption? A true supereruption, classified as a magnitude 8 on the Volcanic Explosivity Index, is an event of almost unimaginable scale, ejecting over 1,000 cubic kilometers of material. Yellowstone has had 3 such eruptions in its history: 2.1 million, 1, 3 million, and 631,000 years ago. These are immense, irregular intervals, and there is no evidence to suggest that Yellowstone is due for another. In fact, based on past activity, the annual probability of a supereruption is estimated to be about 1 in 730,000, a risk far lower than being struck by a kilometer-wide asteroid. If such an event were to occur, it could generate a massive ash cloud, blanketing much of North America and potentially causing temporary global cooling. But this is the absolute worst case and lowest probability scenario. Crucially, a supereruption would not happen without warning. The geological forces required to produce such an event are immense, and they would signal their intent for years, if not decades, in advance. Scientists at the Yellowstone Volcano Observatory, or YVO, would expect to see dramatic and unmistakable signs: intense earthquake swarms with thousands of tremors strong enough to be felt, rapid ground deformation rising by feet instead of inches, and massive changes in gas and heat emissions. The caldera would literally be cracking at the seams, and it would be obvious to everyone that something unprecedented was happening. So what is the current status? The YVO, a partnership between the U.S. Geological Survey and other institutions, operates a dense network of monitoring instruments 24/7. Right now, all data shows typical background activity. The 1,000 to 3,000 small earthquakes per year are normal for the region. The ground continues its cycle of rising and falling by a few centimeters, a process of geological breathing that has been observed for decades. Gas and thermal emissions are stable. The official USGS alert level for Yellowstone is green, indicating normal non-eruptive behavior. Public fear often comes from myths and misinformation, amplified by media looking for a dramatic headline. But the science tells a much calmer, more nuanced story. It's a story of a dynamic, fascinating, and intensely monitored geological system. While Yellowstone's power is immense, the data shows it is currently in a state of repose. by trusting the science and seeking information from credible sources like the USGS, we can appreciate this natural wonder for what it is, not for what we fear it could be. Yellowstone is powerful but predictable in its signals. Myths spread faster than data, so let's stick to measurements. For more science without the hype, subscribe to KnowverseTV.